All right, so problem number 5 up at the top of page 7, it says write and solve equations to find measurements. We want to find the value of x and BC if B is between A and C. So the very first thing we're going to draw a picture. And this thing right here where it says we're looking for BC, we want the length of segment BC. All right, so let's draw a picture. It says that B is between A and C. So I have A on one end. I have C on the other end. And point B is somewhere in between them. We're told over here that AC is 4x minus 12. So this distance right here is 4x minus 12. AB is x. So this distance right here is x. And then we have that BC is 2x plus 3. So right here, 2x plus 3. There are 3 segments in the picture, 2 small ones and 1 big one. If you take the 2 small segments and put them together, you get the bigger segment. What are the 2 smaller segments that are being put together? What are the 2 smaller segments in the picture? X and 2x plus 3 are their measurements. You're looking at the right spot, but I want the names of the segments, but you're looking in exactly the right place. AB is one of them, and BC. When I take AB and put it together with BC, what is the name of the larger segment? AC. Perfect. So we're going to take segment AB, the small, littlest one, put it together with BC, which is slightly larger but still small. And when I put those 2 segments together, I get the big one, AC. All right, so now I'm going to substitute in their measurements. In the place of AB, I'm going to replace that with the measurement that was x. I'm going to drop down my plus sign. In the place of BC, what are we going to replace that with? 2x plus 3. Drop my equal sign down. What are we putting in the place of AC? 4x minus 12. Beautiful. And now we are going to solve this for x. So the first thing I'm going to do, I want to stay just on one side of the equal sign, and I want to see if there's any like terms that need to be combined together. Are there any like terms that I should combine together over here on the left? X and 2x. What do you get if you combine x and 2x together? 3x. So I have 3x plus 3 equals 4x minus 12. Now I need to get my x's to the same side. So I'm going to minus 3x from both sides. What is 4x minus 3x? 1x, or just x. I love it. That's exactly right. So I have 3 equals x minus 12. What do I do now? Plus 12. We're going to add 12 to both sides because that is the inverse operation of subtraction. I want to undo that subtraction over there on the right. So I have 3 plus 12, which gives me 15. 15 equals x. That is part of what they asked me to find. It says find the value of x, and we did that. And then we also want the length of BC. Absolutely right. BC is 2x plus 3, and we're going to substitute in the 15 in the place of the x. So 2 times 15 plus 3 33, yes. We have 30 plus 3, so BC is 33. Very nicely done. Right. Let's look at about the halfway point on the page now. If we have two geometric figures that have the exact same shape and size, exactly the same shape and size, then we say that those figures are congruent. When I have two segments that have the exact same measurement, we say that they are congruent segments. And we use these little tick markings here to indicate congruence. Congruence marks. Sometimes there's just one little tick mark, like here. Sometimes you want to indicate that these two lines are the same size, and so we'll put two little tick markings on them. They could even have 3 tick marks on them. What we're looking for is, do they have the same number of little markings on them? These two segments are the same size as each other. They're both 1.7 centimeters, but these segments are not the same size as these ones over here, because these have 1 tick mark on them and these do not have 1 tick mark on them. If they all had 1 little red mark on them, then we're saying that they're all the same size. If it has the same number of little marks on it, then we're saying that it's the same size. This symbol right here means congruence. It's an equal sign with a squiggle over the top. And the way I would read that sentence right there is segment AB is congruent to segment CD. If segment AB, with a dash over the top of AB, is congruent to segment CD, with a dash over the top of CD, then the length of AB, AB with nothing over the top, is equal to the length of CD, CD with nothing over the top. So if the segments are congruent, then their measurements are equal. If it has the little dash over the top, we're talking about the segment, the actual stick. Those things can't be equal, but they can be the same size as, in which case we call it congruent. When you leave the dash off the top of the letters, you're not talking about the object anymore. You're talking about how big it is. You're saying the size of segment AB is equal to the size of segment CD. That's what that bottom statement is saying there. So far, so good? All right. Let's see if we can use this idea of congruence to solve some problems. Down at the bottom of the page, number 6, part A, says find the value of x if q is between p and r. PQ equals 6x plus 20, QR equals 2 times x plus 6, and PQ is congruent to QR. Remember, congruent means same size. All right. If you are not in the habit of drawing pictures when you're looking at these math problems, that's something that is going to have to change if you want to be successful in geometry. when they're describing these line segments and talking about their sizes, we need to have a visual reference for that. So if they don't give you a picture, you need to draw a picture. So I'm going to draw my line segment here. It says Q is between P and R. So I have P on one side. I have R on the other side. It says that Q is between them, and I'm being careful putting it at exactly the halfway point this time because, remember, PQ, the distance from here to here, is the same as congruent to QR. So from here to here. So I'm going to put those little slash marks on it showing that they're the same size. PQ and QR are the same size. It tells me that PQ is 6x plus 20. And QR is 2 times x plus 6. In geometry, if you have things that are congruent, like PQ and QR, that means their measurements are equal. So I'm going to rewrite PQ, but without the dash over the top. And I'm going to change the congruent sign to an equal sign. QR gets rewritten, but without the dash over the top. So here I'm talking about the actual segments. Here I'm talking about the length of the segments. And when I talk about the length of the segments, now I can substitute in numbers or expressions that I have for those pieces. So PQ was 6x plus 20, so I'm going to put that in for PQ. 6x plus 20 equals, in the place of QR, we're going to put 2 times x plus 6. And now we're going to solve this for x. When I look over at the left side of the equation, that just looks really normal, right? Is there any like terms to combine if I'm just looking at the orange part? No. Over on the other side, the light blue part, I see parentheses. I want to get rid of those parentheses. What operation will let me get rid of those parentheses? Multiplication, distribution, absolutely. So we're going to distribute that 2 inside the parentheses. I'm going to bring down my 6x plus 20 equals 2 times x gives me 2x plus, what is 2 times 6? 12. And now we have a two-step equation. We're going to get our x's on the same side. So I'm going to minus 2x from both sides. So I have 4x plus 20 equals 12. Then I'm going to minus 20 from both sides. What is 12 minus 20? Close. Negative 8, yes. 4x equals negative 8. Then we divide both sides by 4. And what is negative 8 divided by 4? Negative 2. So x equals negative 2. Very nicely done. Because PQ and QR are the same size, we actually have a special name for point Q. It's exactly at the halfway point of the big segment, and so we call this the midpoint. It's the same thing as if you take the words middle and point and run them together to make one word out of it. So instead of calling it the middle point, we just call it the midpoint. But it means it's in the exact center. Let's try part B. It says find the value of x if u is between t and v. I'm going to pause right there and we're going to draw this picture. So I need a segment. It says that u is between t and v. So t is on one end, v is on the other end. U is in between them, but I'm looking at this right here, just a couple lines down, because what does that say? What does this say right here? It's not. Means that it is congruent. So not congruent would have a slash through that. Just kind of like how not equal is an equal sign with a slash through it. Not congruent is an equal sign with a squiggle over the top and then a slash through it. So these are congruent. What letter is the same between both of these? U. That means U is that middle point. So U has to go exactly at the halfway point here, or as close as I can get it. This segment is the same size as this segment, so I'm going to mark them with congruence marks. Remember, it doesn't matter whether I use one slash or two slashes, or I could even do 3 slashes on each of these. It just has to match. The two pieces that are the same size have to have the same number of markings on them. All right. So then it says that TU is 6x plus 35. So right here, 6x plus 35. And UV is 4 times x plus 7. 4 times x plus 7. First thing I'm going to do is write down my congruence statement again. Segment TU is congruent to segment UV. The very first thing I'm always going to write down on a problem where I have a midpoint or where I have two congruent segments. What was the next thing that I did back on problem number 6 after I wrote that down? What's the next thing I wrote down after this on the previous one? Yeah. Yes, I wrote it without the slash over the top and without the squiggle. I'm going to say the length of segment TU is equal to the length of segment UV. So equal sign instead of congruence symbol. Now I'm going to replace TU and UV with their measurements. So 6x plus 35 is equal to 4 times x plus 7. What do I do now? Distribute. Yes, we're going to take this 4 and distribute it. So I would have 6x plus 35 equals 4x plus 28. Where to now? Yep, we're going to subtract 4x from both sides. So minus 4x on both sides. 6x minus 4x gives me 2x. So 2x plus 35 equals 28. Then I'm going to subtract 35 from both sides. 2x equals how much? Super close. -7, yes. 2x equals -7. Then we're going to divide both sides by 2. What is -7 divided by 2? X equals -3.5. Absolutely correct. Okay. I have you. Give me just a second. I want to say it's desk 12 right here, but let me double check that. Yes, I have you in desk 12 right there, and I'll get you the papers that you need.
Okay, thank you.
You're welcome. All right, nicely done. Let's go ahead and flip the page. All right. The segment addition postulate. If Z is between A and B, then, and then there's some blank space. We're on page 8. So I'm going to put points A and B on here. Here's a point A. Here's my point B. It says that Z is in between those points, but it did not say it was at the halfway point. So the length of segment AZ, the smaller one on the left, plus the length of segment ZB, the smaller segment on the right. When I add those two lengths together, it gives me the length of the larger segment, AB. All right. We're going to write 4 true and 2 false statements using this line right here. And it can be a little bit hard to see where those points are. Point A is here, and then B, C, and D. So something true that I could say about this, I've got 4 points here instead of 3, but if I take segment AB and put it together with segment BC, if I add those two together, what's the big segment that it would give me? AC, yes. AB plus BC equals AC. I can take segment AC, this one right here, and put it together with segment CD right here. If I add segment AC and segment CD together, what segment would it give me? AD, yes. AC plus CD equals AD. I have 3 smaller segments in the picture. 1, 2, 3, right here. If I take all 3 of those and add them together, AB plus BC plus CD, what would it give me? AD. Segment AB plus BC plus CD equals AD. What about if I had segment AD? So I have this whole thing right here, and I decide to subtract out AB. What would I be left with? BD, yes. AD, the big segment, minus the part that's at the front, AB, is going to leave me with BD. All right, so there's 4 true statements. 2 false statements now. Segment AB plus segment CD equals segment AD. Who can tell me why this one is false?
There's no BC.
AB is this part right here. CD is this part right here. If I add just the parts that are shaded together, I've skipped this middle piece, so I don't have the whole big long stick. Perfect. All right, another false statement. AC plus BD equals AD. Why is that one false?
There's no BC.
Well, let's look carefully. AC would be this much right here, right? There's AC. BD would be this much right here, correct? Well, I got this piece, I got this part, but then I got that part again, and then I got this piece over here. So I counted BC in the middle twice instead of just one time. So this would be like taking a stick like this and putting them together and saying that I got something shorter because it's crossing over at that place. Does that make sense? Awesome. All right. Now list all the distinct names for the line segments on the line. And this is going to be probably the last thing that we do today. We'll finish up tomorrow. All of the distinct line segments. So if you guys remember from yesterday, I told you how I walk through this to make sure that I get all of the pieces. I start over on the left and I go 1 dot. And then I go 2 dots, and then I go 3 dots, and if there's 4 dots, then I go 4 dots. I get all the way to the end on the right, and then I start back over on the left, but 1 dot in. So let's start walking through that. So AB would be my first segment. What's the next segment I would list? From A to B, then I would go AC, and then what? AD. Have we gone as far to the right as we can? Yes, okay, so now we're going to start back over on the left, but I've done everything that uses A. So we're going to go to B. What's my next segment? BC. And then BD. Can we go any further to the right? Nope. So I'm going to start back, only I've already done everything with A. I've already done everything with B. So C. And that, what would that segment be? CD. Perfect. Absolutely fantastic. All right. We have 3 problems left to finish up on page 8 tomorrow. And then you guys will have the remainder of the class time to work on the next homework that you should have picked up on your way in the door. If you did not, please make sure you pick up one of those homeworks before you leave the room. Typically, we won't have half a day that we can spend on homework, but tomorrow is class meeting days. If you are a freshman, you will get pulled out of here right at the beginning of class tomorrow. Sophomores, you will get pulled at the beginning of 2nd period. Juniors will get pulled at the beginning of 3rd period. And seniors will get pulled at the beginning of 4th period. You'll go down to the Performing Arts Center when the announcement comes on. In this class, we only have a couple of freshmen in here, so just the freshmen will leave. Everybody else will stay, and we'll continue these 3 problems. What you will need to do, though, is to look on Canvas for the remainder of these problems. So from the Canvas homepage, you want to go to Modules. Once you click on Modules, we're going to be here in Module 1. You'll find the date. Here's Tuesday's date, so here's today. Tomorrow you'll be where it says Finish Line Segments. I'm going to show you yesterday's as an example, though, what it looks like once the video has gone up. So when you click on the page that you're looking for, this is yesterday's page. If you scroll down about 2/3 of the way down the page, there's notes on the right-hand side of the page, and there's a video of class on the left-hand side of the page. So I will go over those last 3 problems tomorrow. If you're a freshman, you'll have to come in and watch the video. Video will be posted right around lunchtime tomorrow. All right? Homework assignment is due on Thursday. New homework is due on Thursday, and that will also be the date of your first skills check. You will have your first skills check on Thursday.